Aside from slope-intercept and general or standard form, there is another form that equations can take, and that is also very useful when dealing with these, which is called slope point form. This is particularly useful when you have the slope of a line and a point on that line. And the way that it works is, well, we have to go back to when we had our slope formula, which is y2 minus y1 over x2 minus x1. And if we rearrange this, if we multiply both sides by x2 minus x1, then what ends up happening is this side multiplies by x2 minus x1, and so does this side multiplies by x2 minus x1, and these ones cancel out, and we get a formula that looks a little bit odd, but is actually quite useful, where m is now multiplied by x2 minus x1, and on the other side you just have y2 minus y1. Now if you know a slope, then you will know this m value, and if you know a point, you will know an x and a y value, and I'll call them x1 and y1. You'll know one of the points that it goes through. And so this equation can be written, well, I know one point it goes through, but I don't know some other points that it goes through. So another point would just be x comma y, and so that might be your x2, y2 if you think about it that way. So this formula can become, well, I know my slope, I don't know one of my x's, but I do know my other x, the x1, which is given to me as a point, and then I don't know my y2, it's some other point that I don't know, but I do know my y1 value that was given to me. And we can use this to quite quickly get the equation of a line, as long as you know this basic equation. Now, this is generally written this way instead, just flipping it around. Y minus y1 is equal to m times x minus x1. You don't need to know how to generate this formula, though it is useful because the slope formula is on the data sheet that's given to you by the government for the provincial test, but I don't believe this formula is given to you on that sheet, but you can fairly easily calculate what it is if you understand how it's made from the slope. Applying it actually is really quite easy, so let's take a look at a couple of examples with the application. So our example is to find the equation of the line that passes through 4, negative 5, and has a slope of 2. So using this equation, y minus y1 is equal to m times x minus x1. And let me just shift this up a little bit. I know my slope, so I know that my slope is 2, so I just substitute that in. So I know it's going to equal 2, and I know my x1 and my y1, so I just plug those ones in as well. So I get y minus negative 5. Just be careful with those when they're negatives, because you're subtracting away a negative. And x minus positive 4, which becomes y plus 5 is equal to 2x minus 4. And I'm well on my way to getting the equation of the line with these conditions. Now, we don't generally just stop here. Sometimes we do, but usually we state the equation either in terms of y equals mx plus b, or we state it in general form. So let's see how we might switch it around so that we can get it into these two forms. If you want it into y equals mx plus b first, well, right now we have y plus 5, and I just want y, so I would subtract 5 on both sides, and I would get y equals 2x minus 4 minus 5. And just to give myself a little bit more room on this question, I would see that that becomes y equals 2x minus 8 if I distribute this, and y equals 2x minus 13. And now I have it in the form y equals mx plus b, and it's fairly easy to graph if I wanted to graph this. For the general form, I want to get it into the equation ax plus by plus c is equal to 0. And so I start with y plus 5 is equal to 2x minus 4s. I don't want to have multiplication with these brackets, so again I distribute that out. I get y plus 5 is equal to 2x minus 8. Got my x's here, so let's move everything over onto the right hand side. So if I subtract a y from both sides and I subtract 5, I can make this side equal to 0. That's like this equals 0 part, and so I get 2x minus a y, and then the minus 8 and the minus 5 become minus 13, and there is my equation in general form. Let's just try one more example. Okay, we're going to find the equation of the line that goes through these 2 points, 1, 4, and negative 2, negative 3 in general form. Well, my form that we're working on currently requires me to have the slope and a point, not 2 points. But the slope formula will allow me to get the slope when I have 2 points. So let's use it. Y2 is negative 3 minus y1, which is 4, over negative 2 minus 1. You get negative 7 over negative 3, and that's the same as positive 7/3. Now I have my slope when I go to use my formula, which is y minus y1 is equal to m times x minus x1. I have my slope, here it is, this is my m, so I can plug it in for here, 7/3, and now I can pick either point. It will not make a difference if you use x1, y1 as 1, 4, or if you use negative 2 and negative 3 for your x1 and y1. I would say it's probably easier to use 1, 4 because you don't have the double negatives. So you get y minus, so this will be our y1 and our x1. Y minus 4 is equal to 7/3 x minus 1. So I've got a start on my formula, but I need to get this into general form, and general form needs to look like ax plus by plus c equals 0, and they all have to be, a, b, and c have to be integers, and a has to be positive. I've got fractions, so like we saw in the past, the easiest way to get rid of fractions is to multiply everything by a common denominator. So 3 multiplies, you get 3y minus 12. 3 multiplies, that cancels out the dividing by 3. You don't multiply it through to the brackets as well. And then you get 3y minus 12 is equal to 7x minus 7. I want to get all the x's by themselves. There they are over on the right hand side. So I need to subtract 3y and add 12 to get 0. So now I've got 0 on this side. I'll have my 7x minus 7. I'll take away the 3y and I'll add 12. Let's collect like terms and put it in the right order. Minus 3y plus 5. And there is my answer in standard or general form. Okay, well, hopefully this is making some sense to you. It's a lot of algebraic manipulation, and really knowing the this new formula for if you know the slope and a point, and how it combines in with some of the old formulas like the slope of a line. At least there's no graphing yet with this form, but again, if you wanted to graph from this, turn it into slope-intercept, or if you've got it in general form, graph the intercepts and connect the dots. Everything is a straight line in this unit, so it's a little easier than some of the things that we saw in the last unit with domain and range and functions that were curved. All right, we'll see you in class to practice this.